Good morning.
Good morning，还可以的。Hi, good morning, everyone. Today we are going to solve equations. We are going to solve exponential equations and logarithmic equations. So let's look at number 12 here. Number 1, look at the equation we are having right now. 2 to the power of n plus 1 equals 2 to the power of 4n plus 3. This is an exponential equation. It is an equation and the unknown appears in the exponent. That makes the equation an exponential equation. Normally, we like to use x to be the unknown or the variable, right? But this problem has n as the unknown. So we are solving for n. We're solving for n. Look at the left side and the right side. We notice the left side and the right side, the two exponential expressions share the same base. The left side, base is 2, exponent is n plus 1. Right side, base is 2, exponent is 4n plus 3. The left side and the right side, they have the same base. Means this part is the same. The yellow part is the same. And the left side equals the right side. And the yellow part is the same. Would that make sense? The blue part supposed to be the same as well. If you think about it, left side equals right side. and the yellow part are identical. The yellow parts are identical. Then we should have the blue part equal to each other, right? So we have the blue on the left equals the blue on the right. And we are going to solve this linear equation in n to find the value for n. And what we're going to do is we're going to minus n from each side and cancel that. We have a 1 on the left side. We have a 4n minus n, 3n plus 3. And then minus 3, 1 minus 3, -2. And then positive 3, -3 cancel, so we have 3n. And then we divide each side by 3. 3 cancels 3. Then we have n equals -2/3. All right? That's how we solve this equation. This exponential equation is very basic. It's very basic. Left side is an exponential expression. Right side is also an exponential expression. And both of them have the same base. If they have the same base, they should have the same exponents to make the equation a true statement. All right, so that's the first equation. The second equation, we have 1 over 5 to the power of x plus 4, x plus 4 equals, on the right side, we have 5 to the power of, I believe that's 8x minus 2. 8x minus 2. As you can see, I have two methods, method 1, method 2, for solving exponential equations. And the first method applies when the left side and the right side of the equation could be written in the same base, okay? Could be written as an exponential expressions with the same base. The first question we just did, they already have the same base, so very straightforward. And in the second question, they do not have the same base right now, right? Left side, the base is 1 over 5. Right side, the base is 5. However, we can see how closely related the two bases are. 1 over 5 and 5, they're reciprocal of each other, right? So we should be able to rewrite left side and the right side as exponential or powers with the same base. How about let's do 5, because 5 feels better than a fraction. Could we write 1 over 5 as a power of 5? 1 over 5 is the reciprocal of 5. Could we write 1 over 5 as 5 to the power of -1? Everything else stays the same. Everything else stays the same. I can highlight this part and this part. So this step, all we have done is to rewrite 1 over 5 as 5 to the power of -1, because the idea or the method is to write both sides as the powers with the same base. We decide to use 5 because it's very convenient to write 1 over 5 as a power of 5. 1 over 5 is just 5 to the power of -1. And then on the left side, we are going to apply a power rule. Power rule that you have learned from Foundation 2. I didn't mention a lot of Foundation, this you're supposed to know this, you're supposed to know that from Foundation 2. And that is a fact. I actually really think, if you think this course is challenging, that because the parts that from Foundation 2 probably challenges you. What is the power rule? X to the power m and then to the power n. We keep x and then multiply the two exponents, m times n. If you are familiar with that, the left side can be written as 5, keep the base 5, and then multiply the two exponents. Multiply -1 and x plus 4. So we have a -1 times x plus 4. -1 times x plus 4 is just a negative. parentheses x plus 4. So that's the left side. Right side keep the same the entire time, ax minus 2. All right, now the left side and right side, they have the same base. See if I can move the formula. Move the formula somewhere else. Here, okay. And now the two sides, left side, right side, have the same base. Base is the same, so they should have the same exponents. Okay, so we're gonna have the pink part on the left equal to the pink part on the right, ax minus 2. And we're gonna solve this equation. How about let me just erase this. I can write a formula here. We used this formula earlier. Okay. Distribute. When the coefficient of a parenthesis is -1, and we need to distribute, remove the parentheses, what we do is to change everything in the parentheses to their opposite. Okay, because the negative sign serve as opposite. For example, we have 5. What's the opposite of 5? You just need to put a negative sign in front of it. The opposite of 5 is -5, right? So the left side gives the opposite of x plus 4. Without the parentheses, we're going to have the opposite of x and the opposite of 4. -1 times x, -x. -1 times 4, -4 equals 8x minus 2. All right? And then since we have 8x positive on the right side, we are going to isolate the x on the right side this time. We are going to add x to each side. Negative x, positive x cancel. And we have -4 equals 8x plus x, 9x minus 2. And then we add a 2 to each side. -2, +2 cancel each other. Then we have 9x on the right. -4 plus 2, which is -2 on the left. And then we divide each side by 9. We have x isolated on the right. And on the left, we have -2 over 9. So the solution of x, the solution of the equation is x equals -2 over 9. Should have left more space here. Also, okay. Put it back like that. All right. Right, so x is -9 over 2. Sorry, -2 over 9. So that's how do we solve the first type of exponential equation. All right. What's the first type of exponential equation? When is possible or convenient? Mainly is convenient. Okay, technically it's all possible. If it's convenient to write the exponential expressions on both sides of the equation as powers with the same base. If it's convenient, then we're gonna do it, right? Like number 2, we write both sides as powers with base 5. If they have the same base, then they should have the same exponents, and then we can solve for x. And that's the idea of the first method, all right? To write both sides as powers with the same base. I can write it down. Write both sides. First method, write both sides as powers with the same base. And then equate their exponents. That's the first method. Any question, guys? Do you have any questions?
Nope, it seems pretty straightforward.
Okay, very good. Would you like to try one just very quickly, a simple one? Let's say this one. Can you solve this equation? 3 to the power of 2x equals 27 to the power of x minus 1. Give you 2 minutes. When you see 3 and 27, you should make the connection between the two numbers, right? We know 27 is 3 cubed. The first method applies here. We should be able to write both sides as the powers with the same base. We're going to use base 3.
I got x equals 9/7. So a 9/7.
Really? Hold on. It's not 3. It's not 3. X equals 3. Can you double check? Let's do it together. Left side 3, 2x. Right side 27 is 3 cubed, right?
Oh, that's where I messed.
Oh, it's okay. Yeah, x to the power m and then to the power of n equals x to the power m times n. So we can multiply these two exponents. Don't forget the parentheses. 3 times, I'm using red. 3 times parentheses x minus 1, right? Yeah, parentheses. And 3 to the power of 2x on the right side, 3 to the power of, okay, we actually can equate exponents here. So the base are the same now. They should have the same exponent. The 2x and the 3x minus 1 should be the same. 2x equals 3 parentheses, yeah, x minus 1. And then we have to distribute 3 times x, 3x, 3 times 91, 93, and then minus 2x, 0. 3x minus 2x, x, minus 3, plus 3, plus 3, 3 equals x, or x equals 3, right? Yeah. You know, it's not very difficult to double check. My proposed solution is 3, and if I plug in back, I can see my answer satisfies the equation. Plugging in x equals 3, then the left side is 3 to the power of 6, and the right side is 27 to the power of 2, which is also 27 is 3 cubed, right? 3 cubed and then to the power of 2 is also 3 to the power of 6. So it does satisfy. I emphasize this, when it comes to solving equations, we should always double check our proposed solution, especially when you have a calculator. All right. That's the first method for solving exponential equations. Now let's look at number 13. What if the left side and the right side of an exponential equation, is hard or not convenient to write them as powers with the same base? For example, number 1 in this topic. 2 to the power of x minus 3, not 5, minus 3 equals 11. Okay, 11. As you can see, left side has base 2. Left side has base 2. Right side is a constant, but if you really want, you can write it as 11 to the power of 1, right? It also can be written as an exponential expression. It's just exponent is 1. Base is 11. While 2 and 11, I do not see the connection. So it's not convenient to write both sides as powers with the same base, right? If the right side is 8, if the right side is 8, of course it's not. If it's 8, then we can write 8 as 2 cubed, right? And use the first method. However, it's not. It's not very convenient to write 11 as something with base 2. It's possible, by the way. We could, but we don't want to do that because it's not convenient. When this happens, when the first method is not convenient or does not apply, we're going to use the second method. What's the second method? This is the second method. We are going to apply the natural logarithm on each side. So we are going to put ln on each side. By the way, log works as well. Log is the common logarithm with base 10. But I choose use ln because it has 2 letters. Log has 3 letters. That's my reason. Okay, by the way, you could use log, by the way. So the answer sometimes is not unique. All right, so we take ln on each side, right? And let's see what happened after that. I want to separate the middle, like always. Then the left side, I can rewrite it. The left side is ln with base 2. No, not base, my bad. Base is e. Base is e. I misspoke it. Base is e, and the whole thing here is the argument, okay? The argument is 2 to the power of x minus 3. The argument is a power. Do you guys remember the power rule? Log with base b, x to the power of r equals r times log with base b of x. When the argument of a log has a structural power, we can move the exponent in the power in front of the log. I hope you remember this formula. We learned a lot of formulas last time, and this is one of them. So we are able to move this exponent in front. Okay, do not forget to put a parenthesis. Without the parenthesis, the structure would look different. So we're gonna, because x minus 3 is one whole thing, so we use a parenthesis to frame it. And then we move the exponent in front of the log and equals the right side ln 11. All right. How do you understand ln 2 here? Ln 2 here actually right now on the left side is the coefficient of the parentheses. Okay. Our goal, do not forget, our goal is to solve for x. I mentioned that when we solve for x, just like a peeling an onion, x is in the middle, in the center, in the core of the onion. We just need to remove those layers, right? Okay, next layer, the first layer we're gonna remove is gonna be the ln 2. It's just a number, by the way. ln 2 is just a number. It looks weird because it's in a logarithmic form, but it's just a constant. So we are going to divide each side of the equation by ln 2. Then these two cancel each other. ln 2 cancel ln 2, right? Then we have x minus 3 on the left side. We have x minus 3 on the left side. We don't have to use parentheses anymore. And on the right side, we have ln 11 over ln 2. As much as it looks complicated, it's just a number, okay? It's just a number. And then we add 3 to each side, almost there to peel the onion to isolate x, right? Then -3 positive 3 cancel. Then we have x equals ln 11 over ln 2, and then plus 3. And that's the answer. That's the answer. Depends on how the requirement instructing you. Some of them requires you to enter the exact value. Then you just enter this. This is the answer. Sometimes they ask you to enter a decimal, round to how many decimal places, and you just have to do that. And let me get the TID for calculator. In this course, I'm pretty open for any type of calculator you want to bring to the testing center. So you have to figure out which calculator you want to take with you. So let me stop share this one and then share my calculator. Remember, x is ln 11 over ln 2 and then plus 3, right? Let me double check. Yeah. So in a calculator, we can do this. ln 11 close the parentheses divided by ln 2 close the parentheses. So the parentheses is necessary for the programming of the calculator. They want you to pay attention to the argument of the log. So that is the quotient, and then we're gonna add a 3 on top of that. If we need to enter the answer as a decimal, let's say rounded to 3 decimal places, then the answer is going to be 6.459. All right. Yeah, as I said, maybe it doesn't. Maybe it just lets you to write the answer exact it is. So then you just have to enter that in the Lumen in the system. All right. So let me summarize. If the first method of solving exponential equations does not apply or not convenient, it's not convenient to write 11 as a power of 2. Is that possible? Again, it is possible. We can write 11 as a 2, log with 2, 11. You might remember the formula we have learned, right? But I don't think a lot of people remember this formula. That's why I did not use that method. So it's not convenient, so we're gonna use the second method. What's the second method? Take ln on each side. All right, that's the first question. Second question, number 2. 10 5x minus 4 equals 7 6x minus 8. Exponent is 6x minus 8. All right, so this is an exponential equation. Variable x appears in the exponent. Left side is an exponential expression. Right side is also an exponential expression. Left side, the base is 10. Right side base is 7. Not very convenient to write them as the same, as the power the same base, right? So we consider to use the second method. Because we have a 10 here, of course you can do ln, no problem. The method I introduced just now works very well. But you know what, I want to play with this problem a little bit. Since the left side has the base 10, this time I'm going to do log, common log, log, and log. And let me separate the left side and the right side. And the left side right now is log. Log means common log, okay? Common log. So you don't have to write base 10, or if you want, you can write base 10. And then 10 to the power of 5x minus 4. That's the left side. Right side right now is log with base 10. 7 to the power of 6x minus 8. Okay. The argument on the left side is a power now. The argument on the right side is a power now. And we can use the power rule to move the exponent in the argument in front of the log. So we're going to move the exponent in the argument, this part, in front of the log. Move this part in front of the log. Then we would have, please do not forget the parentheses. Yeah, 5x minus 4 is the whole thing. Use the parentheses. And then log with base 10, 10 equals, same thing, 6x, use parentheses, minus 8 times log with base 10, 7. Question, what is log 10, 10? What is a common log 10?
4.
Awesome, very good. If we have a log whose base and argument are identical, then the value of the log is 1. Very good. So that's the reason I did not use natural log, instead use common log, right? Because we don't have a 1 here. And cancelled because it's multiply. So we have 5x minus 4 on the left side. On the right side, we have 6x minus 8. I'm gonna use log. You know, I like to use the big L. When it comes to common log, I like to use big L og. Otherwise, if I use lowercase l, I just very wanna put a base there. So allow me to do that. So big L, like a common log 7. Okay. Now we are gonna solve this equation. We're gonna solve this equation. This equation is just a linear equation. I guess the confusing part is log 7. But knowing that is just a number. Log 7 is a number, okay? It is a number. If it helps, we can write a number in front of log capital L. 7 in front of the parentheses, maybe you can see it better or more comfortable. And left side, we do not need to distribute because it doesn't have a parentheses. If we use ln, we would have to do that part. But we are using log, so we have a 1 on the left side as a coefficient, so we don't have parentheses. So knowing this is a coefficient of the parentheses, so now we're going to distribute. And we're going to have log 7 times 6 and times x. I'm going to write 6 in front of log 7 and then times x. All right. And then minus 8 log 7 and then times x. So that's what we, oh, no x, I'm sorry. Gosh. No x. So log 7 times 6x minus log 7 times 8. Okay, that's the right side. Okay, that's the right side. Again, I want you to see that this is just one number. It's just a number. This is just also a number. It's just number. Okay, so as you can see now, the equation has 4 terms. 2 of them with x, the other 2 without x. And we are going to collect like terms. This time I'm going to isolate the x on the left side, okay? We are going to subtract 6 log 7 times x from each side. Subtract 6 log 7 times x from each side. Then they cancel. On the right side, we only have the number -8 times log 7. Left side, those 2 terms, they both have x, right? They both have x. If you don't see it, I can just copy it. 5x minus 6 log was 7x. And remember, we have a minus 4 here. And we don't want a minus 4 on the left side. We want that term go to the right. And we plus 4. And they cancel. Then on left side, we have 5x minus 6 log 7x equals, I know I have seen this a lot. As you can see, the real challenging part is your algebra ability. If you can solve those without making mistakes. And those are not new for pre-calc. This is solving linear equation. And on the left side, as you can see, those 2 terms both have x. How about you can see them as like terms and combine them, or you can just factor x out, right? If we can just factor x out because they both have x, then we have 5 minus 6 log 7 equals -8 log 7 plus 4. All right, almost there. I know it's very long. It's very complicated. And this part right now in the parentheses, that's the coefficient of x. That's a number. Almost there to isolate x. So now we're going to divide each side by that coefficient. 5 minus 6 log 7. And here's the same. 5 minus 6 log 7. And they cancel x isolated on the left side. On the right side, it is -8 log 7 plus 4 all over 5 minus 6 log 7. That's the exact answer. If the question requires you to enter a decimal, you would use your calculator to get it done. All right. Yeah, I know it's quite complicated. This is the answer. I didn't mean to do that. This is the answer. Any questions? So you either do ln or do log. ln is a natural log, log is the common log. The reason we do that because the calculator has log and ln. We do not use other bases. It doesn't help if we use other bases. That's number 2. Okay, number 2. Number 3. Did I copy this question? I'm going to use this space here to number 3. E to the power 2e to the power 4t. E to the power 4t. See if I copy anything wrong. 12, not 4. Double check. 2 times e to the power 4t. That's the left side. Right side, 2 terms, 10 plus 12 times e to the power 4t. Okay. Yeah, we're going to use the space here on the left side. Let's use pink. This. All right. 3 terms. What I see is the 3 terms. And I notice 2 terms are like terms that we actually can combine them. This term and this term should be collected and combined. To do that, we can minus, if you don't mind to use a negative, minus 12 e to the power 4t. Minus 12 e to the power 4t. Cancel on the right side. On the right side now, we only have 10. On the left side, 2e 4t minus 12e to the power 4t. So 2 minus 12 is negative 10. Negative 10e to the power 4t. What happened is, on the left side, you have 2 star minus 12 star. So you should have 2 star minus 12 star. You should have a negative 10 star, right? Yeah, they are the same same expression, the star. So 2 star minus 12 star give you negative 10 star. Oh, it doesn't let me do anything else. Okay, let's do that. And we also can get rid of the negative 10 coefficient by dividing each side. By dividing each side by negative 10, right? The negative 10 cancel negative 10, we have e to the power 4t isolated on the left side. On the right side, 10 over negative 10 is negative 1. All right? From here, we can try ln, but doesn't work this time because we cannot have ln a negative number, right? Oh, actually, what happened? Yeah, what happened? Let me double check my copy. 2, 12, 10 is there. This equation does not have any solutions. Yeah, anybody see why? This equation doesn't have solutions. Why?
Because it has a negative number?
Yeah, because the left side, this is exponential function. We know exponential function and it's growth, okay? Because the base e, the Euler number, remember, is about 2.718. So it's bigger than 1. Bigger than 1, so the left side is an exponential function that is increasing. So the graph look like that. So the whole function is supposed to be bigger than 0. That's the range of the exponential function. So the left side is not possible to be negative 1. So this is a contradiction. Right now we have a contradiction. Because the left side, the exponential expression, is not possible to be negative number. So the equation has no solution. No solution. It's possible, right? No solution for number 3. Okay, let's summarize the second method. The second method to solve an exponential equation. When the first method does not apply or not convenient, and we use the second method. How do we apply it? We apply ln on each side, and then use the power rule to move the expression with x in the exponent in front of the log. You can see sometimes it's not that bad, sometimes it's very long, like this one is very long, and it really tests your algebraic ability. What is that? Means that you can do those distributive property, solve linear equation, and you can see what is variable, what is constant. And those are not new for pre-calc. It's from prerequisite courses. I recorded the class, so I'm recording the class so you can look at this problem again. You know, it's a good idea to repeat it, right? Repeat 5 times to see how do you feel about it. If you don't feel improved, like more comfortable, another 5 times until you feel comfortable and then find a similar problem to practice. You will feel it's very easy. I need to stop to saying easy. It's doable, okay? It's doable. Practice make it perfect. And I know you guys are busy, you have other courses and you have a life, you have family. But this is the standard of our college. This is the standard for pre-calc in our college. What is our excellence is our what? Yeah, the 4 things. Oh, that's so bad. I don't remember that now. We keep the standard. You know, you have to reach it. Let's see the time. Okay, we have 40 minutes. Yeah, another 40 minutes. It's perfect time. Yeah, the rest of the class, another part, the other half of the time, we're going to cover solving logarithmic equations. All right, logarithmic equations. Very important thing, as I mentioned in the parentheses. It is a requirement to double check your proposed solution when we solve a logarithmic equation. You don't have to do that for exponential equation, but if you like it, you're welcome, but it's not mandatory, it's not required. But for solving logarithmic equation, the main difference, very important, is we have to check the proposed solutions. I'll explain the reason in a moment. We have 4 questions here. Number 1. What is a log function? Log with base 2, argument x to power, oh, copy the wrong one. Number 1, log with base 2, 4x plus 6. That's the argument. That's the left side. On the right side, we have 4. Oh yeah, log 4. Then okay. So this is the equation. This is an equation. If the variable x appears in the argument of a log, then that equation is a log equation. Okay, the log equation. All right, so we actually have multiple different ways to solve a log equation, but the reason I put this specific question here, this type of question here, is that we can use for this equation, this type of equation. On one side you have a log, on the other side you only have a constant. We use the conversion, okay, conversion. Before we use it, I'm going to let's review it. Log with base b, x. Oh, I'm gonna use the star and the triangle. Base gonna keep as b. Star equals triangle. So this is an logarithmic equation. The 3 part. I hope you still remember the names for the 3 part. B is the base. Star is the argument. Triangle is the log. Remember, the log is a piece of wood. The log is a piece of wood. Someone is carrying it on the shoulder, right? The base is carrying the log on the shoulder. And now we use B, we use triangle, then the other is star. Those two equations are equivalent. They represent the same equation, but this is the equation in the logarithmic form, and this is the equation in the exponential form. So the first method we can apply to solve a log equation, if it's convenient, we convert or rewrite the equation in the exponential form, because we just learned exponential equation, right? Okay, so I'm going to write the name for the three-part space into equal sign. Base, argument, log. We know base is 2. I don't think anybody cannot see that. Base is 2. Can you tell me what's the argument? On the left side, we're talking about the left side of the equation. Log with base 2, parentheses 4x plus 6. Base is 2. What's the argument?
4x plus 6.
Awesome. We're going to use parentheses to frame it, indicates the whole thing, right? What's the log?
4.
Perfect. And now let's convert. Let's rewrite the equation in the exponential form. Base is 2. A piece of wood, log, is 4. We use both, right? We use this one, we use this one. Now, there's only argument left. Then it has to be the other side, 4x plus 6. Right? 2 to the power of 4, 16. Equals 4x plus 6. As you can see, once we translate, we got a linear equation. And the solution, the solving is going to be pretty straightforward, right? Minus 6, cancel. 16 minus 6, 10, equals 4x. Divide each side by 4, We have x isolated on the right side, left side, 10 over 4, 5 over 2. 2 plus 5 or 2 halves. So x equals, 5 halves, my bad. X equals 5 halves. 5 over 2. This one is not very long, right? Not a lot of steps. And the strategy or method that we use is to rewrite the log equation in its equivalent exponential form. Okay? Oh, I forgot to do one thing. Check. Like that. So I just actually emphasize that, right? Check. We need to look at if the value of x, the proposed solution, make the log function on the left side well defined. Because, you know, the argument cannot be 0. The argument cannot be negative either. The argument has to be positive. And as we can see, no problem. X is positive, times 4 is positive, plus 6 is still positive. Yeah, that make the solution fine. That is the actual solution. All right. Yeah, we do need to very important. We do need to check. Very, very important. And that's that problem. That's that problem. It's a good one. Not very, you know, like intricate. Yeah, this problem is very long. This is a challenging one. All right, number 2. I'm going to do number 2 here. Use the space. Log with base 4. The argument is in the parentheses, is a power. X to the power 5 equals -1. Okay? Well, since this equation also has the format, log with base b star equals triangle, right? The method that we use in number 1 also applies here. Yeah, let's do that. Let's do that first. Let's see. Let me write down the name of the 3 parts. Base, argument, log. Base is 4, right? Okay. Argument is the whole thing in the parentheses. Log -1. So let's translate or rewrite. Base is carrying a log on the shoulder equals the third thing. Yeah, we use this one, we use the one, then we have to use this one as well. So x to the power 5th, right? And then we have 4 to the power of -1, that actually is 1/4, the reciprocal of 4. X to the power 5. And if that makes you comfortable, we can switch the left side and the right side. Like I'm feeling more comfortable with x to the power 5 on the left side. And that really doesn't, you know. And then I'm gonna apply the second method of solving exponential equations. I'm gonna apply ln on each side, okay? And the left side we have ln x to the power 5th. On the right side we have ln 1/4. And the left side, since the argument is the power, exponent is 5, we can move the 5 in front. And we have 5 ln. Oh my gosh, hold on. X to the power 5. Let me see if this works. This actually, oh no, it's not an exponential equation. The base x, the x is in the base, not exponent. The x is in the base, not exponent. So how do we, okay, this is what we can do. What we can do is to write a 1/4 as log x, oh, no, this one. We can do, oh gosh, this is a power function. This is a power function. What we're gonna do is we're going to raise each side to the power of 1/5. That's it. Okay. Yeah. Now this is not an exponential function equation anymore. This is in the exponential form, but this equation is not an exponential equation. I apologize earlier. This is a power function. Remember, in the first time I tell you the difference between exponential function and the power function, actually for this reason. Because the variable x is in the base, is not an exponential equation, is power. So we want to get rid of the 5 on the shoulder of x, right? So we raise both sides to the power 1/5. Then we use the power rule, x to the power of 5 times 1/5. You know, they're going to cancel, become 1, right? So we have x isolated on the right side. And the left side would be 1/4 to the power of 1/5. Yeah. If you want to write that, I think this is good enough, to be honest. So 1/4 to the power of 1/5. For fifth rule of 1/4 depends on the requirement. Yeah, but I think this is good enough. Let's see what is 1/4 to the power of 1/5. Let me double check. 1/4 equals that. So 1/4 to the power of 1/5. Let me stop share the note and then let's go to my calculator. 1/4. The TID for calculator is very convenient. Close the base and raise to the power of 1/5. Start a new parenthesis, 1 divided by 5. It's a decimal. Yeah, depends on how you round it. Around or equal to 0.76. Around or equal to 0.76. Did I share this? Oh.
No, we can't see your calculator.
Sorry, yeah, I forgot to share that. Yeah, I'll do it again. 1/4. Close the base and then raise. Do it again. 1/4. Close the base and then raise to the power of 1 over 5. Starting the parentheses, 1 divided by 5 is around equal to 0.76, right? Yeah. 0.76. If I design a question, I would require the students to enter the answer as a decimal, because that would be a unique answer. Otherwise, you want the students to write exponential form like 1 over 5 or 5th power, so it's not very consistent. So I would actually do decimal. So it's around equal to 0.76. Okay, now stop share the calculator and then share back my note. This here, right? So x is about equal to, that's what I remember, 0.76. Okay, very good. Yeah, so let me emphasize this part. After we convert or rewrite the logarithmic equation to exponential form, we do not really have an exponential equation because the variable x is not in the exponent. The variable x appears in the base. That is a power function on the right. So our goal, like a peel and onion, is to get rid of the 5th power. That's the reason we raise both sides to the power of 1 over 5. Because only when we raise both sides to the power of 1 over 5, we can get rid of the power 5 to isolate the x on the right side. All right? Yeah. Okay, so that is number 2, a little bit more complicated than the first question. Now let's do number 3. Can I actually copy this? Copy this. I'm going to enter a new page here. Insert a blank page. Yeah. I'm going to do number 3 here. Number 3. Number 3 is a log equation, and it has 2 logs, with variable x appears in both. And that is one reason we learned condensing. Last time, we learned expanding, we learned condensing, right? Okay, condensing the left side. Right side is just the 1, just leave it right now. Left side, we have a subtraction, a difference of 2 log with the same base. The base is 10, okay? It's common log. It doesn't show up, means the base is defaulted as 10. And we're going to condense the left side as 1 log, and we're going to use the quotient rule. We learned last time, log with base b x minus log with base b y equals log with base b x over y, right? Quotient rule. After we condense the difference as a single log, the argument is going to be a quotient. That's where the name quotient rule comes from. Let's do that. I'm going to separate the equation, left side, right side. And let's condense the left side. I'm going to use the color scheme. Yellow, blue, so green, blue. Okay. Right. Left side has a base 10. Okay, we're going to keep the base 10. Allow me to use log, capital L. To condense, the single log gonna have an argument in the structure of a quotient, So the numerator of the quotient is going to be the yellow, the argument of the first log. The denominator of the quotient is going to be the blue, the argument of the second log, x plus 2. It's good to have a parentheses. Without the parentheses, this one is fine. This specific one is fine. But with the parentheses, just make them more clear. Okay. All right. And now we have the form that we have seen earlier from, oh, I have skipped the page. In this form, right? Log with base b star equals a triangle. Now we get that again. Then let's use the conversion. Yeah, let me write a conversion here. LG with base B star equals triangle. Base is B, triangle is a log equals the star. Those two equations are equivalent. They are the same equation, just looks different in different form. The base in our case, base is 10. It doesn't show because default is 10. Argument is x plus 3 over x plus 2. Log is 1. Let's translate, convert. Base 10 to the power log, log is a piece of wood on the shoulder of the base, equals the argument. Okay, it's just 10. I want to switch the order because I like to isolate x on the left side eventually. Okay, this step didn't have much, just I switched the left side and the right side, and then write 10 to the power, first power as 10. What type of equation this is? This is actually rational equation. Okay, rational equation, we want the right side be 0, remember that? Yeah, we are solving exponential or logarithmic equations, but actually we are using other type of equation solving skills. And we want a minus 10 from each side. We want to isolate the right side as 0. Then we have x plus 3 over x plus 2 minus 10. I'm going to write 10 as 10 over 1, right? So we have x plus 3 over x plus 2 minus 10 over 1 equals 0 on the right side. We have 0 on the right side. And the 10 over 1, I'm going to rewrite 10 over 1. I'm going to multiply x plus 2, x plus 2. Then we have x plus 3 over x plus 2 here. And we have 10 times parentheses x plus 2 over x plus 2 here. The reason, the purpose is to make the two exponential expressions have the same denominator. Now they have the same denominator. Keep the denominator. Solve the top. X plus 3 minus 10 times x plus 2. Those small details matters, you know. I'm going to simplify the top right here. X plus 3 minus 10 times x plus 2 is blue color. Equals x plus 3 distributive property. Negative 10 times x, negative 10 times 2 is negative 20. Combine like terms, x minus 10x, negative 9x, 3 minus 20, negative 17. So the numerator now is negative 9x minus 17. Yeah, over x plus 2 equals 0. If we have an exponential expression equals 0, that means the numerator, similar with fraction, okay? If we have fraction equals 0, we're going to know the numerator must be 0, denominator is not 0, okay? Yeah, similar with this. So we have the numerator must be 0, negative 9x plus negative 7 equals 0, and x plus 2 cannot be 0. Right? Numerator has to be 0 in order for the quotient to be 0. Denominator never be 0. That's common sense. And then we can solve this equation on the left. Plus 17. We have negative 9x equals 17 divided each side by negative 9. X equals negative 17 over 9. That's the proposed solution. And that solution will not make, yeah, we actually have to check. Oh, did I check in the number 2? Did I check this question? X equals, oh, that's fine, that's fine. Because this solution 0.76 is positive, to the power 5 is still positive, so the argument is positive, is well defined. But I did forget, I apologize. We do have to look at it very quickly. Check, very important. when you take the test, you know, you do have to leave a little time to check. Some error, like this type of error, can be spotted right away, right? Well, there's no error, it is a solution. I got this. Okay, we have a solution -17/9. Let me write it down. Solution is x equals -17/9. Is negative, be very careful. And we want to see if it make the if it satisfy the original equation. Oh, hold on. Oh, this is positive. This one is also positive, actually. It works. It works. Even x is -17/9. -17/9 is bigger than -2. You know what I'm saying? So if we plug in the yellow, I'm doing the blue color. So the yellow is x plus 3, right? If we plug in x equals -17/9 plus 3, so -17/9, we can write 3 as 27/9, because 27 divided by 9 is 3. And as you can see, the result is 10/9, right? Okay, so here's the log with base 10/9, and minus log. Let's see the blue. I'm going to do it here. The blue is x plus 2. So if we plug in x equals -17/9 here, I'm going to write 2 as 18/9 and get a 18 minus 17, 1/9. So here we have log with base 10 of 1/9. It works. It works. So it is a solution, okay? But we, of course, need to be very cautious when we get a negative number. Sometimes even we get a positive number, we still have to check. You know. So suppose here the yellow. Look at the yellow. If here's minus, the solution will make the argument, the yellow part, negative, and that is not well defined. We have to give up the proposed solution. Okay, sometimes it happens. Yeah, very, very important. We have to check our proposed solution when we solve a logarithmic equation. Sometimes the solution is extraneous. We remember extraneous solutions from previous chapter, right? When we solve rational equation and radical equation, we do have to check, because when we change the structure of the equation, we removed or we expanded the domain. The domain is supposed to make the yellow positive, the blue positive, because arguments have to be positive. But when we get rid of the structure, we remove the restriction, the domain expanded. When the domain is expanded, we might invite in extraneous solutions. So very, very important to double check. That is number 3. It's pretty long. Ooh, pretty long, right? Okay. Number 4. I do need a extra page. Here. I'm gonna page breaker. Okay, now I have the whole page for this question. Number 4. I believe this is just the stem, this part. I don't think that's something significant. Okay, so number 4, we solve this equation ln x plus ln x minus 4 equals ln 7x. This time, the equation has a 3 log, natural log with base e. and no other things, just the 3 logs. So in order to solve for x, to isolate x, peel the onion to expose x, we have to, condense. Firstly, we want to condense the left side because it's an addition. We condense one at a time, right? Unless they are all addition, if we have LOGB star, if we have LOGBX plus LOGBY plus LOGBZ, if they are both star addition, if they are all adding even more log base BW, then we can condense in one time, keep the base B and then multiply all the arguments X, Y, Z, W, right? That's done. But here we can predict if we move this term over to the left side, we're gonna have a subtraction. So that does not help or cannot go with condensing this part. So we are going to condense the left side first. When you walk, when you drive, you have to look forward a few, miles ahead, right? Same thing. When we do things, we have a prediction. We look a little bit forward. We condense the left side using the product rule. LOG with base BX plus LOG with base BY equals LOG with base BX times Y. The condensed log has argument X times Y. It is a product, and that's the name of the rule come from, product rule. So the left side we can condense, and I'm going to use this color scheme as well. This is the separator. Okay, left side is an addition of 2 logs with same base, so we can condense by using the product rule. Keep the base is E, you don't have to write it out. By the way, if you want to write ln with base, it's log with base E, okay? You cannot do ln E. Okay, you cannot do ln with base E. We don't have that. If you write the base out, ln is log base E, or you just keep it, just ln. Multiplying the 2 arguments, so have yellow times blue, yellow times blue, and this is good enough. X times blue. If you really want, we can put a parenthesis here. It doesn't hurt. Okay. Oh, actually, you know what? We're almost there. Good thing. 7x. We don't really have to condense by moving ln 7x over, because you know what? The left side equals the right side, right? This part, the pink part, is the same. That should lead to the green part, the same. You see what I'm talking about? If you have an equation, if you have an equation, left side log with base B star, right side log with base B a heart, right? And the left side equals right side. The 2 logs are identical. They already have the same base. Obviously, they should have the same argument. This is the case. The pink parts are already the same. We just need to equate the green part. Then we have x times x minus 4 equals 7x. Oh, we're going to have a quadratic equation. Yeah, we solving exponential logarithmic equation, but after we remove the structure, it becomes a linear or quadratic, sometimes, radical. Yeah, we have to deal with that. Distribute x times x, x squared, x times 94x equals 7x. Oh, not too bad. We don't have constant, that's the reason. Minus 7x, right side is 0. Left side, x squared minus 11x. Negative 4 minus 7, negative 11. This is an easy quadratic. It's not even trinomial. It's a binomial. We can factor x out. Factor x out, then we have x minus 11 equals 0. All right? So if you remember, how did we solve quadratic equation? I'm gonna write the left side like this. You remember that? X minus 0 is x, I know that. But I just want to show you the structure. So we can write the left side as x minus 0 times x minus 11. The solution is going to be the opposite of those two red numbers, right? 0 and positive 11. Positive 11. Do we check? Very, very important. We need to remember to check. Now we have two proposed solutions, 0 and 11. Let's go back. Let me write this down. The first solution, proposed solution, x equals 0. Second is 11. Let's see. 0, can we do 0? Can we keep 0? Could 0 be a solution of the original given log equation? That is a difficult question. Log with base b star, the argument has to be positive. Remember, very, very important. Argument has to be positive.
Then no, 0 cannot be a solution.
Perfect. Thank you. Thank you. Appreciate that. You answered it right. No. Extraneous. 0 does not work. 0, the equation, the original equation, we are solving the original equation. The original equation is not defined at 0. X cannot be 0. What is other than 0? You try, the calculator will tell you it's error. The argument has to be positive. What about 11? Let's see. 11 here, 11 minus 4 is 7. 7 times 11, 77. 11 is fine. So you only have one solution. You only have one solution. All right? So I cannot stress that more. It's so important to remember to double check the proposed solution when solving a log equation. Something like this will, if we don't do that, if we don't check, we put a 0 there, we got no point, even we have spent so much time to do this, right? All right, that's everything for today. We actually finished. The last section of this unit is application of exponential function. So we have some questions. Do you think we can stop here? Do you have any questions? Let me look at who is participating today. Can actually look at here. Kaida, Esther, Michael, Liza. Only 4? The entire time only 4 people? Okay. Let me go to mark the attendance for today. One, 5, see this one. Today. Okay, that's here. Michael's here. Max is not. And cosine 来算一下。All right, that's everything for today. Feel free to email me if you have any questions.
Excuse me?
Yes,
Could you scroll down a little bit?
scroll
Please.
down the note. Okay.
Yeah.
Here,
Yeah, thank you.
no problem. We do have a transfer. Students want to transfer to the university, and you might, yeah. So we want to really, keep the standard, really prepare you for that. We don't really want to water down the standard. So those questions are good questions. They are challenging, but they are good questions.
Well, I'm gonna leave and work on the homework.
You need to work on your homework.
I'm gonna leave the Zoom call.
Oh, okay. All right, guys.
Thank you for class today.
Thank you.
Thank
Thank
you.
you guys for coming. I'll see you on Thursday.
See you. Bye.
Bye bye.